All right, are these all going to be named the same way? Ooh. So which two are going to be named the same way? First one and the last one, because on those you're going to use what?
This stuff up there?
No, not for those two. What are you going to use for the first one and the third one? The prefixes. Thank you. Prefixes. The middle one, that's when you would have to use your ion sheet. And the middle one's an ionic compound, but there's not a transition metal, so you don't have to worry about that as far as putting that charge in parentheses. No, not for the second one. The first one. Okay.
I mean, third one.
The two that are non-metals, those are covalent compounds, so you would use your prefixes.
That's what I was thinking. Oh, I didn't see this.
All right, so this week what we got going on is 2 quizzes and 1 test. Quiz today and quiz on Wednesday over acids, what we're learning today. And then your nomenclature test on Thursday. I'll either give you a formula, you write a name, or give you a name and you write a formula. There's no quiz review for it because you got a whole pile of practice. So if you can do your practice, you'll be in good shape for the test. Hopefully doing a lab on Friday. And then our last quiz will be on Monday, and our journal test will be on Monday. And then we'll test, I'm not for sure what day y'all test on. Test is open notes on Thursday, and our last quiz will also be open notes. So there will not be any retest or re-quiz for the one that's next Monday. We have a few things, the nomenclature, the covalent, most everybody passed that. So I should have very few today. We're doing the ionic and we're doing the acid. So those will be able to be re-quizzed if you need them. And then we got tutorials going on. I got them posted in a couple of places. But yeah, if you come into my room before school and it's open, because I know I left it open with all my lights on, then that means somebody's called me to come help them with something. And I've got teachers out all over the place with and having to help them get situated. So just hang there and I will come back, I promise. All righty, let's do our quiz. If you go into your lovely Google Classroom, I'm gonna like 2 weeks when we don't have to say that. Down to quizzes, let me drop it real quick. You need to put everything up except for your pink sheet, your periodic table / ion sheet. All right, you should be looking for quiz number 2, ionic. Somebody will give me a thumbs up when they got it. All right, okay, good. Got 10 minutes. Try that one more time. All right, one more time on this. Okay, so an acid compound that will produce a hydrogen ion when dissolved in water. So an anion, remember anions are negative, bonded to a hydrogen is an acid. So any compound starting with a hydrogen is going to be classified as an acid, and you're going to follow those acid rules that we're going to talk about. So that means, yes, even water can be an acid. Even though acids usually contain nonmetals, they are treated as ionic compounds because the hydrogen ion is present as an ion and not as an atom. So they must be neutral. So like we did with our ionic compounds, whenever we start writing formulas, we have to make sure our positives are equal to our negatives. So what you're going to have is you're going to have hydrogen combining with either your negative ions up here or your negative polyatomic ions. They make up two different kinds of acids, and there's two different sets of rules for naming those. All right, so our first type of acid is called a binary acid, bi meaning two. So that's whenever hydrogen is just combined with one other atom. So that's when hydrogen is combined with one of your anions up here on your ion sheet, not with the polyatomic ion. And to name those, you start with the prefix hydro, then the root of the second element, and then they always end in ic. If it starts with hydro, it has to end in ic. Those two go together. So if I was looking at HF, the first thing I would think to myself, it's an acid because it starts with hydrogen. So I got to go to my acid rules. And then since it's combined only with one other element, it's a binary acid. So it needs to have hydro as a prefix, root for fluoride or fluorine is fluor, and then it ends in ic. And then you have to put on the word acid. Like I said, if it starts in hydro, it has to end in ic. HCl, same thing, hydro prefix, root chlor, end in ic. And then put on the word acid. So those are my binary acids. The other type of acid, the second type, is an oxyacid. So that contains hydrogen when it's bound to oxygen and one other element. So that means hydrogen is bound to a polyatomic ion. So those are going to be those at the bottom listed as polyatomic ions. When you have hydrogen bound to one of those, it's called an oxyacid, and we no longer use the prefix hydro. Instead, we name it based off of our ion, and we change the ending. So if the ion ends in ate, I change it to ic. If the ion that makes it up is in ite, it becomes us. So same thing here. If I was looking at this one, I would think, all right, it starts with a hydrogen. So it's an acid, but it's bound to a polyatomic acid. Polyatomic ion, not just one element. So I'm not going to use hydro. So I would have to find NO3, which is nitrate. And we said 8 becomes ic. So this would be nitric acid. Same thing, next one I have hydrogen. So I know it's an acid, but it's bound to a polyatomic ion, so I'm not going to use hydro. So I locate my polyatomic ion, it's nitrite. So ite becomes us, so that's nitrous acid. All right, so why don't y'all take a few minutes and try those 6 right there. Using your ion sheet and give them a try. All right, let's go over a few of these and see what you got. H2SO4. It's really sulfuric acid, but I would definitely take sulfic. Sometimes on a couple of these acids, it's like some old ways have kind of hung in there. So, but you had your sulfate, so the rule was 8 became it. What about HI? Yeah, hydroiodic, sounds weird. Acid, definitely sounds weird. HBr, hydrobromic acid. H2S, yep, hydrosulfic or sulfuric acid. H3N, hydronitric acid. Never actually seen that. H2SO3, sulfus or sulfurous acid. Yep, all right. All right, now when it comes to the fact that you're given the name and you're trying to write the formula, like we said earlier, it's treated like ionic compounds. So that means our positives must be equal to our negatives. The charge must be balanced. So overall, it's neutral. It's a little bit easier because the cation is always hydrogen, which is a +1. So there's a little trick. If you'll look at whatever anion you're combining it with, if you'll take its charge and make it positive, that'll always become the subscript for hydrogen. Remembering that you would never write a 1, that would just be understood. And then you have to kind of work backwards. If I have phosphoric now, then you have to think, what did that come from? If it's ic now, then originally it came from what polyatomic ion? Phosphate, right? Which is PO4 with a -3 charge, because 8 becomes it. If I'll take that -3 and make it positive, it'll become the subscript for my hydrogen. And my formula will be H3PO4. By doing that, my hydrogen has a +3 and my phosphate has a -3, so it'll be neutral. All right, nitric acid. If it's nitric now, then originally it would have had to be what? Nitrate, which is NO3 with a -1. They're acids, so all of these are starting with hydrogen. The nitrate is the -1, so I'd make that positive, but we don't write a subscriptive 1, so I just would put HNO3. If you put your NO3 in parentheses, that's fine. If some of y'all are liking to do that every time you get a polyatomic ion. Chloric would have been originally what? Chlorate, which is ClO3 -1. So once again, if it's -1, the hydrogen doesn't need a subscript, so it just be HClO3 with or without parentheses for the ClO3. Carbonic, if it's carbonic now, originally it would have been carbonate, which is CO3 -2. So that has a -2, so I have to make that positive, and that'll become the subscript for my hydrogen. So I'll have H2CO3. That way I have a +2 and a -2, and they cancel each other out. Phosphorus acid would have had to be in white. What? Phosphite, which is PO3 -3. So what's going to be the subscript for my hydrogen? 3, and then I put my PO3 in or out of parentheses. Now, if you have something like hydro, I can't spell, it's supposed to be bromic acid, or if it starts with hydro, then you know it starts with hydrogen because it's acid. And then remember, it's not going to be combined with a polyatomic ion. It's going to just be combined with a single element. So brom would be the root for what? Bromine or bromide. Bromide's a -1, hydrogen's a +1, so I don't need a subscript. Hydrofluoric acid. HF, exactly. What about hydrosulfuric acid? You know, it starts with hydrogen, and then what else? S, what is your S? What's the charge on your S? But remember, this isn't sulfate because this comes, sulfate is a polyatomic ion. If it's hydro, then it's hydrogen just combined with an ion up here, single ion. -2. So I would need a what from a hydrogen? +2. So it would have to be, I don't know why that does that. H2S. Because this is sulfide. Sulfide's a -2. So I have to make it positive. And that becomes my subscript for my hydrogen. All right. Not too bad. So in your practice, this is like to the third section because we've done covalent, we did ionic, then there's a section on acids. We'll quiz on Wednesday, and then the final section is what you'll see on the test. Just all mixed. You'll have covalent, ionics, acids in there, so you'll have to know for sure what you're dealing with and then name it properly. So if you're dealing with an acid, what's it going to start with? Hydrogen, and you're going to go to those rules. Yes, ma'am.